Hello, everybody. This is Mr. Joseph. I hope everybody's doing okay during this time. I know it's not the easiest time, but I hope we're all staying healthy, getting some exercise. I hope some math might help you also. So today we're going to talk about the volume and surface areas of prisms. So to start this, I think it's important to know what a prism is. A prism is a solid with two parallel congruent bases joined by faces that are parallelograms. A prism is named by the shape of its bases. So to break down that definition, this shape in front of you that you see, this is called a cube. A cube is a 3D shape made out of 6 squares. A cube is also a prism because it says it's a solid with two parallel bases joined by faces. So first, let's look at the base. So I'm going to highlight the bottom part. This is our base, and it's a square. If I took this shape and I also flipped it, this top could also be considered a base. So base, base. So both of these bases are congruent and they're also parallel. And they're joined by faces that are parallelograms. So imagine you start with the two bases and then you put the other squares around it, and a square is a parallelogram. So this is like this right here is a face. This is a face. The one in front of us is a base, and the one behind is also a face. Not to confuse you, I mean, the bases are also faces, but we distinguish the top and bottom by calling them a base. And as you recall, a parallelogram is a four-sided shape. Remember that opposite sides are congruent and parallel. I mean, in addition to that, opposite angles are congruent. Depending on what type of parallelogram, there'll be other properties. What you need to know is some other parallelograms are squares, a rhombus, a rectangle. So just know that the sides that are around the bases have to be a parallelogram. So if we look at the shape in front of us today, we are trying to find the volume of a cube. I think it's important that we know what volume is. So volume is the amount of space that a shape takes up. So imagine having a box and thinking about like how much can I fit in this box, or how much water I can fit. So the best way that we normally approach finding the volume is to think about starting with the base. So we're going to start our story at the bottom base, and we want to take our base and stack it. Because when we stack our bases, it's going to end up forming a cube. So a great way to find the volume of a shape is just to take the base area and multiply it by the height. So once again, imagine you take your base. It's a cool color, by the way. You take this and you just stack it. And you see how you'll reach up here eventually? And it'll cover everything. But the way that you'll tell how many of these you have is you're going to look at the height. And in this case, don't forget it's a cube, so they're all squares. So let's say that our A is 2 inches. So to find the volume, let's first find the base area, which is length times width, and then times height, and as you can see, volume just equals 2 times 2 times 2, and you get 8 cubed inches. And that's pretty much it for volume. This idea of getting your base area and multiplying by the height will work for prisms. Other shapes might be similar, but there'll be some other caveats about it, so we'll get more into those later. But for now, just keep in mind that you'll take your base area and just multiply it by the height. Okay? So below, we are going to move into a different topic called surface area. And we're still looking at the same cube. This flattening of our cube, this is called a net. So when you want to find the surface area of all the faces, it's really helpful to break your box into a net. And as you can see, a cube has 6 sides. So we have, a cube has 6 faces. So when we flatten it, we have 6 squares. And so we're going to use the same numbers from the other examples and say that all the sides are 2 inches. And as you can see, we can keep writing this. But the simple way to find your surface area would just to be take the area of 1 square. So that we're just going to do length times width. And then multiply that by 6, since we have 6 squares. And as you recall, each side is 2 inches. So we will get 24 square inches. Also, take a look at the units, right? We're talking about area when we do surface area. So when we're talking about surface area, we're talking about 2D. The shapes are flat, so our units is square inches. But if you go up earlier, we're talking about a 3D shape, and so that's why you see cube inches. So we're going to take what we learned from these 2 examples and go on to a triangular prism. So this picture can seem a little deceiving because it seems like this is your base. But recall that it's not. That's not your base. Because the definition of a prism is the 2 bases that we have, the other faces have to be a parallelogram. And we know that a triangle is not a parallelogram. So this picture is just not in the right orientation. But this triangle right here is a base, and this triangle right here is also a base. So you need to think about this shape in a different orientation. So we're going to do the same thing that we did earlier. Recall that volume equals base area times height. A triangle can be a little tricky sometimes because we tend to forget the area of a triangle, but it's just going to be a half base times height times, I'm just going to go ahead and highlight the height of the whole prism. So we already know that's 14 centimeters. That's not, can't write with a highlighter. That's 14 centimeters. So when you're finding the area of a triangle, remember that the height is the altitude of the triangle, not the 10. So the 10 is not the height. You need to find the altitude, or the top of the triangle to the bottom. So here the volume equals 1/2 times 8.3 times 10. And I just wrote them backwards just to make it clear. The base is 10. Because the base is 10 here, that means that this is also 10. And then we're going to multiply that by 8.3. And then we have the times 14 from earlier. And the math to this will be our volume, which I will calculate right now. It will be 5 times 8.3 times 14, and we get, great number, we get 581 cubed centimeters. Okay? And that's pretty much it for the volume. Now when we move on to surface area, it gets a little bit more interesting now, because now we have different rectangles with different sides, and we have triangles this time. So we're gonna go back to the original picture and erase everything, and just take a clearer look at the dimensions of this prism. So if we look at our triangle, we know that this base right here and this right here is 10. And we know that because if you look here, this is 10 and this is 10. The long side is 14, and you can see that here with this flat rectangle. 14, 14. And since we're finding surface area, we know we're gonna eventually find the areas of the shape. So we need to know the height of our triangle, which is 8.3. So right now we can check this triangle, we can check this triangle, and we have the bottom rectangle. We accomplished this rectangle right here. So the rectangles we need now is this one and the one that's also to the other side of it. So now let's be careful. It's still not bad because you see the bottom is 10 and 14, but when you see the one that's slanted, this one right here, we can make this highlighter a little thicker. Let's see if that works better. So we're just gonna look at this one. Yeah, sorry, it's my first time dealing with this coloring. So we're gonna look at this side right here. And as you can see, it's 14 and 10. So we can conclude that this is 14 and this is 10. And the reason why I'm going through this is because it's not always going to be 10, 10, and 10. So as you can see, this triangle is an equilateral triangle, so they all end up being 10, but you might have some cases where they're not the same. So to calculate this, so the surface area equals, we have 2 triangles. So we're going to multiply that by 1/2 base times height, plus 3 rectangles times length times width. So once again, it depends on your scenario. It depends how your shape is being broken up. But in this case, we had 3 congruent rectangles and 2 triangles. So we will get 1/2 times 8.3 times 10, all this multiplying 2, plus 3 times 10 times 14. And I'm just gonna leave it there, just for time's sake, but we can easily just put this in our calculator. Also, it's not bad, let's just do it. Actually, 1/2 times 2, that goes away, and we get 240 plus, we got 30 times 14, 420, and we end up with 860. We didn't really give this units, but we know that whatever the units, it would be squared, so we can just go ahead and say centimeters. Okay? Sorry. And our last shape is going to be a rectangular prism. This time, instead of the base being a square, it's going to be a rectangle. So to do volume, we know it's base area times height. And we see that our base is just 3 times 2, and our height is 6. And we get 36 cubed centimeters. So once you get comfortable, you'll be able to do it quicker. Surface area. This one looks a little interesting. So as we recall, I believe that the small ones, this right here, is our base, and this right here is our base. So we know this is 3 and 2. They already said this is 3 and 2. So we know 2 of our rectangles, so we can say 2 times 3 times 2 plus. Now let's look at our other shapes. So they said that this is 2 also. So this is 2, and we know this is 6. So this skinny one, let's give it a blue color. This one right here. And that's going to be the same as this one right here. So it's 2 times 6 times 2. And then our last one is, do we see that it's 3 times 6? And it's this one right here also. And the cool thing about a rectangular prism, especially if you've seen like an Amazon box, I would suggest getting a box and breaking it down and seeing if you get three pairs of rectangles. And so we should have 6 times 3. And now we have 12 plus 24 plus 36. These are all multiples of 12, so that's cool. So that ends up being 36 plus 36, which is 72 square centimeters. And that's pretty much it. I'm sorry for my pictures. This is my first time using an Apple Pencil and actually screen recording, so it's been quite an experience. As my students know, I'm a funny drawer anyway. So I hope that helps. Let me know if you have any questions. You can always email me at myoseph@mnps.org, or also reach out to your teacher. Like I told you, my art right there, my @ sign was not beautiful. Anyway, I hope everybody has a great day, and thank you.